Hello friends, let us start with the speed control of three-phase induction motor. Okay, so we have already seen the torque equation, we have already seen the torque slip characteristics and torque speed characteristics. Now let us move on to the speed control of three-phase induction motor. Induction motor is a self-starting motor, we already know, everybody knows it. But sometimes some application comes where we need to control the speed of the motor. So we have got various methods for the speed control of three-phase induction motor. So these are the methods. The first method is the stator voltage control. The second method is the supply frequency control. Third is the eddy current coupling. Fourth is the rotor resistance control. Fifth is the slip power recovery. In this the two drives comes, static Scherbius and static Kramer. And the sixth is the pole changing method. So these are the various methods. Now the first three methods, they can be used for any type of the rotor. Either it is squirrel cage induction motor or it is wound rotor motor. Okay, so the stator voltage control and supply frequency control and eddy current coupling can be used for both the types of rotors of the induction motor. Okay, but the rotor resistance control and the slip power recovery can be only used for the wound rotor induction motor, and the pole changing can be only used for the squirrel cage induction motor, So I'll just jot it down. Pole changing will be used for the squirrel cage only. Cage rotor. Okay. And these two will be used only for the wound rotor induction motor. And the first three, that is the stator voltage control, supply frequency control and the eddy current coupling. These three methods can be used for both the types of induction motor. Now let us see what are the factors actually which are depending upon the speed of the rotor. So the speed of the rotor is given by, we already know, given by Nr is equals to 1 minus S into Ns. Okay, where Ns is the synchronous speed, Nr is the speed of the rotor. So the rotor speed is given by 1 minus S into Ns. Okay, now Nr is depending upon Ns first of all. Okay, then my Ns synchronous speed is always given by 120 F by P. So if I substitute this value over here, so I'll be getting Nr is equal to 1 minus S into 120 F by P. So my Nr is directly proportional to frequency and my Nr is inversely proportional to number of poles, and also it is depending upon the slip, and also it is directly proportional to the factor 1 minus S. Okay, so these are all the factors on which my rotor speed is being depending. Now let us start with the first method. The first method is the stator voltage control. It is a stator voltage control. So in the stator voltage control, we control the voltage of the stator. The voltage is being provided to the stator, the three-phase voltage. In the three-phase induction motor, we provide the three-phase voltages to the which are having the R by B as the phases. Okay, so we provide the three-phase voltage to the induction motor, and we do not provide any supply to the rotor, but rotor is a self-starting motor. We have already seen the working in which this induced EMF was generated and the rotor started moving. So what happened now? My voltage is being given to the stator. Okay, so my voltage will be proportional to the EMF, because when I will give the voltage, then only the induced EMF will be generated over there, following the Faraday's law. So my voltage will be proportional to the EMF. Okay, and I know my torque equation is given by 3 upon 2 pi ns into s E2 square R2 square plus S X2 square. So this is my torque equation given of the induction motor. So my torque is inversely proportional to speed, to the synchronous speed. Okay, but when I will reduce my voltage, what will happen? The induced EMF will be reduced. Okay, so the current will be reduced. So when voltage is reduced, what will happen? EMF induced will also reduce, and so the current. And because my current carrying conductor was placed in a magnetic field, so it was experiencing a force, so my speed also reduced. Speed also reduced. Okay. So according to this, when voltage is reducing, my speed NR is reducing. But actually from the formula, when my voltage is reduced, NS should increase and NR should also increase, because NR and NS are directly proportional, as we have already seen it earlier. Okay, but this is contradicting over here. This factor is contradicting over here. So this type of method is only applied when I need my speed reduced along with my torque reduced. Okay, so your torque is also reduced. So when I need my torque to be reduced, then only I need to apply this method of stator voltage control. So such type of loads are fan loads. These are all the loads which are in which when the voltage is reduced, the speed is also reduced, along with the current is reduced, and also the torque is also reduced, because my V is also directly proportional to I. According to the Ohm's law. Okay, so when my voltage is reduced, my speed is also reduced, and my current is also reduced, and also my torque is reduced. So such type of method is only used in the applications where my torque reduces along with the speed reduces. This will never satisfy over here. This condition will never satisfy over here. Okay, so let us jot down the disadvantages of this method. So the first disadvantage of this method is that torque also reduces. torque also reduces along with the speed. Okay. The second is the efficiency is very low. Efficiency of the rotor is low. Okay. And the third disadvantage is that rotor gets heated up. Rotor gets heated up because there is large dissipation of heat. There is large dissipation of losses. Okay, of losses. So there is large dissipation of losses in the form of heat. So these are the disadvantages. These are the disadvantages of using stator voltage control method. Okay. Now, how can we vary the voltage of the stator? So the stator voltage can be varied with the help of AC voltage controllers. If only the single phase is there, then the track controller is used. Okay, the track controller can be used. And if there are three phases are there, then we can use the AC voltage controllers. The AC voltage controllers are nothing but devices consisting of the thyristor. So we can adjust the conduction angle, we can adjust the firing angle of the thyristor and conduction period of the thyristor which is being conducting. Okay, so we can adjust that and we can vary the voltages, and as soon as we vary the voltages, we can get this type of speed control in the three-phase induction motor. We can get this type of speed control in the three-phase induction motor. So we can control voltage, control or vary voltage. We can control or vary the voltage with the help of AC voltage controllers. Okay, AC voltage controllers. Okay, in the next lecture we will be studying the diagram of the AC voltage controllers, how the AC voltage controllers is being made. Also we will studying the next methods, the supply frequency control, eddy current coupling, rotor resistance control, slip power recovery and the pole changing. All we will be studying step by step. Okay, so in this method basically what we did, we controlled the voltage of the stator which was directly proportional to the EMF generated. So when the voltage is reduced, the EMF is also reduced, and hence the current, because voltage is directly proportional to the current. Okay, so according to the torque equation, when my NS and torque are inversely proportional, so when my NS is reduced, so what will happen, torque should increase. But here in this type of speed control, the torque is also being reduced when it was applied to the applications such as fan etc. The torque also reduced. So we came to know that in this type of method, what happens is that along with the speed control, when the speed is reduced, the torque also reduces. So this was a major disadvantage of this method. Also the efficiency was also reduced, and the rotor was being heated up frequently. These were all the disadvantages which were stated. Okay, so this was about all the stator voltage control. Okay, please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.